Inverting the post-forecasting pipeline with SPF², Sequential Pointcloud Forecasting for sequential post-forecasting. Let's first review standard post-forecasting pipeline, which contains object detection, multi-object tracking, and multi-agent trajectory forecasting. In this work, we wonder if this standard pipeline is the only option and is there any limitation in this pipeline. One limitation we think is that the current pipeline is expensive to scale because post-forecasting algorithms typically require labeled sequence of object poses. These object poses with correspondences through time are very expensive to annotate in 3D space. So, can we scale post-forecasting performance without requiring additional human annotations? We hypothesize yes, and in this work, we propose a novel post-forecasting pipeline which inverts the order of forecasting. Compared to the standard pipeline, our pipeline can improve post-forecasting performance with the addition of unlabeled data. Now let's take a look at our new pipeline, which we call SPF². Specifically, instead of running detection, tracking, and forecasting, our new pipeline first forecasts point clouds. Then we perform detection and tracking on the forecasted future point clouds to obtain future object trajectories. The difference between our pipeline and conventional pipelines are twofold. First, our pipeline inverts the order of forecasting. Second, the forecasting in our pipeline is at the sensor level because we forecast the point cloud data captured by the LiDAR sensor. Okay, we have talked about the differences. Is there any advantage of our pipeline? First, the forecasting module in our pipeline does not require any human annotation because we can just use the unlabeled point clouds as ground truth for training. Because of this, we can easily leverage a large amount of unlabeled point clouds in order to scale performance of the forecasting module in our pipeline. Both advantages are inherited from the sequential pointcloud forecasting module, which we will introduce next. To support our SPF² pipeline, we also propose a new task, Sequential Pointcloud Forecasting, abbreviated as SPF, which is the challenging first step in our SPF² pipeline. Now, let's take a deeper look at Sequential Pointcloud Forecasting. We already know that this new task does not require human annotation for training and evaluation. What else do we know about this new task? Well, one other benefit is that the prediction of SPF represents the entire scene, which includes information about both foreground objects and background scene. This is very different from prior forecasting tasks, such as object trajectory forecasting, which primarily focuses on objects while ignoring the background information. Our next contribution is an effective approach for the proposed SPF task, which we call the SPFNet. Here is an overview of our SPFNet, which contains 4 modules. 1. A shared point cloud encoder that is used to extract features from past point clouds. 2. An LSTM network to model temporal dynamics of extracted features. 3. A shared point cloud decoder that generates the point cloud in the future. 4. The chamfer distance noise is applied to the predicted and ground truth future point clouds for the training purpose. Okay, let's talk about the results. The first question is that, is our SPFNet effective to the SPF task? To answer that question, we devised a few baselines for comparison. For example, directly copy point clouds from the past, or using ego motion estimation, or using point cloud alignment techniques to propagate point clouds to the future. Lastly, we use one scene flow method to compute the pointwise motion and propagate it to the future. From the results, we can see that our method with 2 different encoder-decoders performed the best, which is reasonable because only our method is designed for non-horizon prediction. Next, we evaluate our new post-forecasting pipeline, which uses the SPFNet in the first step, trained with large amount of unlabeled point clouds. We can see from the results, our new pipeline outperforms the conventional pipeline using various trajectory forecasting methods. Thank you for watching.